Out of all the things in our library of functions project, the greatest integer function is probably the most likely to be the one that you haven't seen before. So this one, you're going to see it written many different ways if you take many different math classes. The first one is int of x. The second one is x with brackets around it. Occasionally you're going to see it written in the third way where you have like, looks like there's an absolute value inside a bracket. Another similar way to that one is going to be with two brackets. And then the last one that you'll see, there's 5 ways that I can think of that I've seen it, is you'll see like a half bracket where you only have the bottom part of it. So just keep in mind all of these are the same things. So if you get to a college class and you see any of these, it's the greatest integer function. And so the definition of it is the greatest integer less than or equal to x. I'll give you like a little bit of help with understanding that. By the way, we also call this the floor function. And so that's why if you look at this way of writing it, it's like the x is in a room with a bottomless pit, but there's also a floor, but there's no ceiling. So it's called the floor function, and I'll give you some ways that you can remember it. The first thing is if you have the greatest integer function of an integer, you use that as your answer. The second thing is if it's not an integer, it's a little more complicated. So if you're taking the greatest integer function of something that's not an integer, you are going to use the next smallest integer. So let's do some examples and then we're going to graph it. So you're welcome to pause the video and try these ones on your own, or you could just wait for me to go over them. For number 1, that one, 5 is already an integer, so our answer for that one is just 5. For number 2, we do not have an integer, so we're going to use the next smallest integer. So 5.2, the next smallest thing is 5, again. For number 3, be careful on this one. We are not going to round this up to 5. We're actually going to go to the next smallest integer, which is going to be 4. -4 is an integer, so that's our answer. So 5 and 6, negatives on these tend to confuse people to no end. So my recommendation is if it helps you, you're welcome to make a number line. So I'm going to go ahead and draw a number line here. You don't need to do that, but it might help you if you're a very visual person. So right now, we have int of -4.9. That's right here. The next smallest integer is going to be to the left of that on your number line, so it's going to be -5. You do the same thing for -3.2. That's about right here. The next smallest integer is -4. So let's graph this. This is an interesting function. So what I'm going to do when I graph this, I'm going to just choose a few values. I'm going to choose some positives, I'm going to choose some negatives, I'm going to choose some integers, I'm going to choose some non-integers, and then we're going to see if we can figure out the pattern. So I'm going to start with a few positives and then we'll do some negatives next. So let's try 0, maybe like 0.2, 0.8. We'll do 1, we'll do 1.3, 1.4, and then we'll do 2. Let's start with those, and then we can do some negatives. So when x equals 0, y is also equal to 0. When x equals 0.2, we're going to the next lowest integer, which is 0. 0.8 is also going to be 0, so let's draw those. So we have a point at 0, 0. We have a point at 0.20, we have a point at 0.80. I'm not drawing them too well because I'm using my finger. Actually, though, you're going to find that anything between 0 and 1 will also give you 0. So I'm just going to draw a line here. The only thing is that when we get to 1, that is going to be 1. So what we're going to actually do to show that we, at the bottom part where we're at 0, that we go all the way to 1 but don't touch 1, is we're going to draw an open circle there. We do the same thing with 1, so 1.3 is going to be 1. 1.4 is 1. 2, though, we're back up at 2. So we have a point at 2, 2. So at 1, I'm going to go all the way to 2 and then draw my open circle. The same pattern is going to continue for every single integer. So let's just choose a few negative numbers. You might be able to guess the pattern repeats. So for example, if we have negative 1, the answer for that is negative 1. If we have negative 0.5, that one is negative 1. If we have negative 1.5, that's negative 2. Negative 2 is going to give us negative 2 again. So let's draw a few of those. So I have a point at negative 1, negative 1, negative 0.5, negative 1. I have a point at negative 1.5, negative 2. I have a point at negative 2, 2. So I have an open circle right here, a straight line there. Same thing happens here. And so the entire pattern continues forever and ever in the negative direction also. So this is what my greatest integer function looks like. This is actually an example of a piecewise function that does not have multiple equations. There's a few of those out there. And it does end up coming up again, probably in calculus, so you'll most likely see this again next year.